Hello, welcome to the video lecture on maximum power transfer theorem. Now, the name itself clearly tells you the purpose of this theorem. So, this theorem tells you the condition in which a maximum power can be transferred from the source to the load. And the condition is given here, like the maximum power is delivered from a source to the load when the load resistance is equal to the source resistance, which you can see it here. Suppose consider this network, you have a voltage source and a resistance series with it. So this represents an electrical circuit, and this is your load. So this is your source resistance and this is your load resistance. Now when you find out a mathematical equation for the power, and you know that for maximization or minimization, the first derivative must be equated to 0. So here I want to find out the condition for receiving the maximum power. So you find out the maximum power equation, and when you differentiate with respect to load resistance and equate to 0, and if you simplify it, you will be getting this equation, that is Rs is equal to RL. So what does that equation tells you means, when you choose the load resistance equivalent, or sorry, when you choose the load resistance equal to your source resistance, in that case the maximum power from the source will be transferred to your load. Okay, so we will verify this theorem with the help of an example. But before that, there is one important point which you have to note it, that is, if you want to apply a maximum power transfer theorem to a network, just look at how it resembles. It is nothing but your Thevenin's equivalent circuit. So, if any given circuit, for any given circuit, you have to convert the given circuit into a Thevenin's equivalent circuit, and then only you can apply maximum power transfer theorem. Okay. Now we'll take an example. Here they have directly given you the Theveninized equivalent circuit. See, you have a 50 volt source connected in series with a 25 ohms. Now you have connecting the load resistance across this point. So there is a resistance and there is an arrow mark symbol which indicates that it is a variable resistance. So you can fix this RL to any value. This is nothing but a fixed resistance and this is your variable resistance. This RL stands for load resistance, that is RL stands for load resistance. Now the question here is, you have to determine the value of this RL, okay, when the load resistance draws maximum power. So I want you to find out what is the value of RL at which maximum power is drawn from the source. Okay, so we all know that just now we have learned the maximum power can be transferred from the source to the load only when RL is equal to RS. So it is clear that it is from the theorem, you can directly write it as, when you choose RL is equal to same as, if you choose RL value same as this equivalent source resistance, then that maximum power will be transferred from the source to the load. Okay, the power transferred will be maximum. So let us verify this. Okay, let us verify and then we'll understand the importance of this equation. Okay, now we'll take this equation as such. Okay, now we'll first find out what is the expression for the power. Okay, so then we'll find out, then we'll apply the theorem. So what is the current value? I is equal to, what is the voltage here? It is 50 volts. So it is 50 divided by, what is total resistance? Total resistance is, it is 25, okay, plus RL. We don't know what is the value of RL, so we'll keep it as RL. Then what is the power transferred? What is the power transferred to this load? So what is the formula for power? Either it can write it as P is equal to V into I, or it is I square into R. We'll take I square into R. Okay. So what is the value of I? Just now we have wrote it now. It is 50 divided by 25. These steps are not necessary for this question. Just I'm writing it for your understanding. So 50 divided by 25 plus RL the whole square into, what is the resistance here? It is again RL. So this is the expression for the power. Okay. So what we will do is, we will take three different values. By the theorem, it states that if you choose RL equal to RS, okay, if you choose RL equal to RS, only maximum power will be transferred. This is the condition. So what we will do is, we will take three different values. We will take RL value less than 25. So let me take 20. we will take RS value greater than 25. So let me take 30, and we will check whether we are actually getting maximum power when RL is equal to RS. So just you have to substitute this 20 in terms of this RL, and then you have to find out the value. So when you substitute these values in this equation, and if you solve it, I am going to write the answer directly. So it is very clear from this tabular column light. So if you choose RS is equal to RL, so in this case, we have taken RS is equal to 1 RL. So only for this condition, the power we are getting as 25 watts. But if, for whatever value, if you choose less than 20, either less than 25 or greater than 25, the power is not the maximum. So maximum power is achieved or maximum power is transferred only when RS is equal to RL. Okay, so this is a slight proof of your maximum power transfer theorem. This is for your understanding purpose, but related to this question, they have not asked you to verify anything. You were asked you they have asked you to find out RL value and the maximum power. We already found it out. The RL value is 25. The maximum power transferred is 25 watts. Thank you.